Hello, everyone. Nice to be here. Happy Friday. I hope you guys enjoying the workshop. So this is the last day. So before I begin, I would like to give you a small story about these apps that I'm going to present to you. These applications were envisioned after discussions similar to this workshop. So we had workshop like this, and we had discussions with participants like you, trying to how we can disseminate, facilitate remote sensing data, how we can facilitate building decision support systems for watersheds and similar to La Plata. And because of that, we ended up having NASA Access, SWAT Online, and other tools. So I encourage you to participate heavily in the discussion in this afternoon. This is going to happen between 2 and 4, I believe, because it's really helpful. We need to know your input. We need to know what is needed by you, because at the end, you will be using these tools and someone else also be using these tools. So to get the feedback from you, it's very, very important to us. So the content of the presentation today, I will give an overview of the NASA Access system. And after that, I will give an overview of the SWAT Online system. And I would like to, and I will try to basically explain how NASA Access and SWAT Online are relevant to the La Plata Basin. And at the end, we will do an interactive tutorial on NASA Access. So this will help you to get motivated to see in action what is NASA Access. And for the SWAT Online, I will give you the URL so you can now see the application in play, because the SWAT Online platform is adopted by MRC. MRC stands for the Mekong River Commission. And we built a decision support system for the Mekong with assistance from the MRC, and now it is working. So the benefits of these tools, what are the benefits of the SWAT Online NASA Access? I try to summarize the benefits into 3 bullets. Number 1, saving time. Scientists, people doing modeling, people analyzing data, trying to work with models, work with remote sensing data or any hydrological models or any meteorological data, are tasked with analyzing various sources of data, and they come into different formats, different ways. So NASA Access is a tool that can help you to retrieve, process, reformat remote sensing data so that it can be easily ingested into your platform, your model. So it is going to fill the gap between NASA disseminating the data and you as an end user using this data. And for the SWAT Online and NASA Access, they are also designed to bridge the gap between non-technical decision makers and technical people. Because if you are technical, you are building models, you are using data from different sources, you wanted to display, communicate the knowledge that you have in your models to these decision makers. And these decision makers, they are not aware of the details that you are dealing with. So they need a nice platform that can convey the information, that can tell them the story that you are trying to say so that they can take decisions. So this is the benefit of these tools. And the last point is the readiness of these tools. These tools are ready for the La Plata Basin to use. So next. So SWAT Online and NASA Access, as I just said, they are hydroclimatic applications. So they are designed to deal with data that is related to climate, water, and they are modular. What do we mean by modular? Modular means they are easy for you to adjust, adapt, change, build upon, because they are open source. So they are available for you. You can download them. You can play with the code to change it the way you want, to the way that can suit you in your analysis. Because as we know, there is nothing called complete. Like everything, everyone needs a specific need. And that need is going to be reflected by you, who is going to change some features, change some functions, so that it can help you in doing your job. They are also available into two different ways. So you can install them in your desktop. You can use them on a daily basis, or they can be hosted by the agency that you are working with, or the department that you are working for, and they can host it by the agency so that it can be disseminated to a bigger audience. Like now, MRC, we are trying to basically install this in the system so that all the countries in the MRC can have easy access to the data. So there is no barrier between the access between this country and that country. So it will be online, and everyone will have the same flexibility in accessing the data and working with it. And I think, yeah, I covered this point. The NASA Access is basically reformatting the data so that it can be easily ingested into hydrological models. As we know, hydrological models are different, and each model needs a specific way for the data to be formatted. So this NASA Access is going to give you a generic ASCII format that can be easily read by these various hydrological models. Because from a remote sensing perspective, if you download IMERIT data, it's going to come in NetCDF file. So the hydrological models are not able to read these NetCDF files. Next. This slide gives you an overview of the NASA Access system. And NASA Access is available into three ways. It is available as an R package. So if you are an R user, you can install the package. It is available as a Python package. If you are a Python user, you can install the Python package. And it is available as a web application. So if you are not into the realm of modeling, Python, R, scripting, and so forth, you wanted a website, you wanted to get the data from it and use it. It's also available like that. And all of that is available in GitHub. So you can easily go and grab the code if you wanted to install the application into the server, or if you wanted to install the application into your desktop. And it's compatible with Windows, Mac, Linux, everything. And the NASA Access can also give you access to climate change data. As you know, now we are trying to know what is coming in the future. So we would like to have forecasts. We would like to have simulations using climate change. So NASA Access is a window that can help you get to CMAP 5, CMAP 6 collections of climate change data. And here, what I'm showing is what you need as a user. You need a shapefile, and you need a digital elevation model for your study site. So for example, if you are working for the whole La Plata, or you are working with a very sub-basin, very small, so you have to have a shapefile, or you have to have a domain, basically, to let the system know, this is my area. I wanted to get data from that place. And after you upload your shapefile and DEM, you select which function do you want. Do you want GPM? Do you want near real-time GPM, data from yesterday? Or do you want the final product from GPM? Do you want GLDAS products? Do you want climate change products? Do you want air temperature? It depends, like which function, which data that you are looking for. After you select that, you tell the system what date are you looking for. It will ask you, okay, for this specific product that you are looking for, this is the available data. From here to here, you select the time duration. And once you have that, then you run the job. And if it is in your machine, you will get the results. If you run this on the server, you put your email, and the email after the job is finished, you will receive an email saying the job is finished. So use this code to retrieve your data. So that is in very quick overview what NASA Access does. If you wanted to just test the web app, it is hosted by the GeoGlows. So you can go to this website and click on this website and experiment the tool by yourself. Next. If you go to the website, this is the interface. So this is the window interface. As you can see, I am here showing these are the functions related to weather. These are the functions related to the climate. This is where you put your DEM and your shapefile. And then you select which functions do you want. And the code behind building this is also available in GitHub. So if you wanted to change it, then you can download the code, play with it the way you want. Next. We use the Tethys platform to build this system. So Tethys is a platform that is really suitable for handling water data. And it has been precompiled by many Python libraries relevant to the analysis. So we use the model view controller, where we have 3 compartments, basically the data storage, the controller, and the view. And here we are using database management, SQL, to handle the flow between the data, as well as the functions that we have, as well as the front end, which is a view, and we are using GeoServer and open layers to display the data. This is just a very simple flow chart that says how the data and how the program basically process your request. Once you put your inputs and you select the functions and you select the dates, the program basically goes and download the data, specifically matching your domain. And after that, processing that, reformatting it. And once it is done, sending you an email, the job is completed, go retrieve the data. What is needed to run NASA Access package? During this week, you have been exposed to different remote sensing data, and you have been asked to register with NASA to obtain credentials so that you can access Earth data. So the same thing here applies. NASA Access needs that Earth data logging that you created so that it can go and fetch the appropriate remote sensing data products. After you create the username and password, then you have to select which data products do you need, because after you create an account, there are so many data sources with NASA. So you have to say, I'd like to be accessing such and such. So in the documentation for the installation, there are steps to tell you these are the data products and these are the data that you should assign yourself to. You have to subscribe to accessing these data sources so that NASA Access can be able to work with you seamlessly. After you create your username and you select the appropriate data sources, what NASA Access needs is to put your authentication login information into a file. We call it NETRC file, and you put this in your home folder. This way, when NASA Access is working, it will touch this file, read your login information, and then submit the job to NASA to retrieve the data product. So before I come, actually, I tried NASA Access on the metropolitan Buenos Aires area, and I just put the domain for the metropolitan Buenos Aires area and used GPM NRT near real time to see the precipitation over Buenos Aires. So this is has not been biasly corrected. So I'm just using the raw data from NASA. And as you can see, I used 1 year of data from 11 November 2021 to 11 November 2022. I'm using the early product with 0.1 to 0.1 degree. And you can see that what I realized on the 27th of February, you guys had a lot of rain in this area, about 154 millimeters. And before I left, it was like 0.4 millimeters. So there was some rain on that day. So this tells you how easy this tool is in accessing real-time information that can help you in your daily work. NASA Access has been used as you remember Mayera when she was saying how we are collaborating with FHI on the Mekong. So here in this paper, we are using NASA Access to examine climate change over the lower Mekong. And here in this graph on the top, these are 4 GCMs with 2 scenarios, RCP 4.5, RCP 8.5. And we are able to see that there is an increase for the annual precipitation trend, about 6 millimeters per year. So handling and processing this data is done easily by NASA Access, because this, if you look, the area of the lower Mekong is about 420,000 square kilometers. Yeah, I know it is smaller than the La Plata, but the case is when you are processing a large area like this to get the signal of climate change, this needs time. And this needs a lot of time in processing and handling of data and working with different climate change models and so forth. In the lower plot, I'm showing the change in maximum temperature and minimum temperature over the region between 2025 and 2095. So that means 70 years of data. Next. There is a web base that basically we call it NASA Access Home. Here, basically, we put everything related to the program, the installation, demos, how you would like to see some results from different areas. So this is the home where you can go, grab the data, grab some examples, grab some demos. And actually, the demos that you are going to do right now has been uploaded here. You can see demos that have been done in Mekong, in other places. So this is, if you have any question, if you have any comments, you can put them in this website. So we read that and then we respond to you. So this is kind of a home page for NASA Access. This basically describes to you when you go, if you would like to install the program, the steps needed for the installation. This is the R version, so I'm not going to go through them. You can read that in your time, the next one. And the same goes with the Python. If you are using Python, these are the steps to do. Next. And this is an overview of the tutorial that's going to happen after we finish this presentation. We will be going through handling data with R. I know some of you using R, so that might not be relevant to you, but if you are interested, you can see that. And then we will be looking at NASA Access demo. So some functions, how NASA Access works, and you see that live. Next, we will be seeing then the decision support system that we built for the lower Mekong, and it's called SWAT Online. So SWAT Online framework is a web-based decision support tool. So SWAT Online, I just want to clarify here, it does not model the watershed online. It is a tool to visualize the model results that you do online. So for example, if we want to apply this on the La Plata, we have a La Plata model that has everything in it. And then we have this tool to visualize the results. That means we communicate the results to the decision makers, to other people who are contributing and working with us. And it is linked to the agency hosting the framework. For example, in the case of the lower Mekong, we are linking this to the MRC. So there is a linkage between the data that MRC disseminates and the model that we built, and the data, the inputs, the outputs, and everything is basically linked together. So this is a linkage between not only the modeling results, but also the data that's been collected and contributed to the MRC to display to the region. So in this platform, we are having 4 methods for visualizing the data. We are having map layer visualization, and we are having subsetting displaying upstream reaches and subbasins. And we are using time series visualization, and we are using raster clipping, displaying raster information. As you can see here, there are different ways to visualize the information, like a map or a time series or a statistics. And this based on the inputs. So the more inputs that you put to the system, the more results that you can obtain. Because here in this case, we are showing land use, land cover, and soil. So if you have more rasters, it will be easy to be implemented because the system has been put in place to handle the inputs. Whatever input that you do, that you have, then the framework can be able to analyze that and give you an easy idea to communicate the results and data that you are showing. Next. The upload and storage methods. So basically, we are having a Python model that can take the data that you produce in your model, upload it to the system, and then display it to the website so that people can see it. And this is done automatically by handling different ways of how you put these rasters. You should put them in the host server, or you put them in the Jew server, and so forth. So all these details have been taken care of. This is the download part. So suppose you are visualizing the system and you are interested into getting some results, a plot, a map, anything from the system, you can easily download that. So you can say, okay, I want to only highlight this area and download the outputs of the model from that area. And I would like to download some inputs from here, from there, from there. Because when you build a system for the whole basin, not everyone is interested into everything. He's interested into his part. He's interested into his area. So the system allows you to go and subset the results, subset the data, matching your region of interest. Next. This is a front view or the home view of the system. We call it the Lower Mekong Hydrological Decision Support System. But the engine is the SWAT Online. So basically, the code that we used to display this was done for a model that we developed for the Lower Mekong. And you can see here on your left, the layers that we are having, the stations that are linked to the MRC. So when you hover in any stations, you can access the real-time data coming from the MRC. You can see the rasters that you have supplied the model with, and you can visualize this in an easy way. Next. So the first visualization method, as I said, the map layer visualization. So you can toggle between each layer that you have. And this can be done with so many layers. So the more layers that you have, you will be easy to display them. So this is just a demo to show you the capabilities, but they are modular. So that means everything that you give, you can be easily seeing it. And here, the access for the raster data. So if you have multiple rasters that you want to display and let people see and play with. So we developed a land cover land use map. Then we also developed the soil map and so forth. So all these rasters are easily seen using the platform. So here displaying upstream reaches and subbasins. So suppose you click on this reach, which is now in red, and you wanted to know what are the upstream reaches. Because if you see, for example, a water quality signal here, you wanted to know who is contributing to this place, who is basically polluting your river. Then you can see all these reaches here in the map. And if you have, for example, another layers for factories or anything, every layer that you have in your analysis, you can easily detect the signal. What is that signal coming from? Who is contributing to it? How can I respond to it? And so forth. And the same goes with the sub-basin. So if you are not interested into the reach itself, you can see all the upstream basins contributing to your basin. So this is an interactive way of going through downstream, upstream context. This is here again, for example, we're just expanding the area of domain. If you selected that reach, you can see that all this area above it is contributing to it. So this is how you can see the difference between when you are in the up basin or in the downstream basin. And the same goes with the sub-basins. This is the time series visualization. So every data that you have that has a time series element, you will be able to visualize it, play with it, and see not only the inputs, but also the outputs. So you have the flexibility of putting all these variables into the column of the time series visualization. So here we are seeing, for example, the stream outflow from a specific reach. So this is a specific reach that we are interested at. And this is the time domain from, say, July the 1st in 2011 to December the 31st of 2011. And this is the stream flow at that reach for that time. Then you can hover, okay, this is the maximum point. This is the amount of the stream flow. This is the date of the stream flow that is happening. You play, for example, if you want to zoom in using this feature, you can see, okay, if you have 10 years of data, 20 years of data, you can zoom in a specific year, in 2 years, and so forth. So you have the flexibility of playing with the data that you have. Another feature related to playing with the rasters. So here, I just want to emphasize, this tool will work based on the inputs that you give it to it. So if you have a very detailed land use land cover map that has, for example, multiple classes of forests, multiple classes of ag lands, then you will be able to really utilize the full feature of this tool. Because if you see in panel A, we have in this specific watershed, 74% is forest, 25% is ag area. If you hover on this forest part, you can easily see that it is now multiple classes of forests, deciduous forest, coniferous forest, other type of forests. So all of that coming from the raster that you have, the detailed data that you have. So based on that detailed data, you will be able to analyze your watershed. And the same goes with agriculture. For example, 25% is agriculture. But within this 25%, how much rice is, how much rice is being cultivated twice per year, and so forth. So a very detailed classes in the ag lands is done by visualizing the specific areas that you are looking at and utilizing the data that you used. Next. If you would like to see a live demo of this, this is the website, and this has been hosted by the Severe Application Management System. So this is part of NASA Severe website. Also, the same case, we have SWAT Online Home. So this is basically a web page that we developed to host all the information related to installing the platform. Any issues with installation, you can put your comments here. Help files to let you guide you through installation or any issues related to the program. So in summary, I wanted to touch upon NASA Access SWAT Online are tools contributed to assist in using information and communication technologies to store, manage, analyze water data. so that more people can understand the water cycle and its impact on the environment. NASA Access SWAT online can assist La Plata Basin countries with near real-time remote sensing data, hydrological modeling capabilities for the entire La Plata Basin. NASA water resources management tools presented are free and publicly available. So everyone is welcome to use them. Everyone can utilize them. Everyone can download them. Everyone can play with it. So there is no any license restrictions on these tools. So these are some references with this work, so you can look them at your pleasure. And with that, I ended my PowerPoint presentation.